Okay, last question of this week. Let's go. You made it to the end. Make sure that you have all 11 questions filled out before you get stamps, okay? Remember that this week I'm going to be grading two things. The Ed puzzles. Make sure you have 100% of all Ed puzzles, or 11 that you watched this week. And make sure you have the notes in your workbook, okay? All the work, all the notes that you copied from your videos need to be on your workbook, and also the past ed puzzles, okay? Please, that's going to be your grade for the week. Don't forget about that. Okay, so let's do this. 14, the label on a package of bolts says each bolt has a diameter of 0.35 inches, okay? So that's how much, let me just edit this real quick. That's how much diameter has to be, right? 0.35 inches. To be in the package, the percent error of the diameter must be less than 5%. Okay, so you cannot have more than 5% error on the diameter, meaning how wide the bolts are. Okay, one bolt has a diameter of 0.33 inches. Oof, a little off. But the question is, can it be still included in the package or not? We need to make sure that it's less than 5%. So should it go in the package? Why or why not? So pretty much, is this 0.33 inch diameter less than 5% error compared to 0.35, which is the optimal diameter of each bolt? Okay, so we're gonna do this real quick. All right, so let's proportion time right now. So we're gonna just go back to our proportion. What is our 100% here? 100% amount that we accept. What is the optimal diameter of the bolts? Yeah, 0.35 is what we need here. Okay, that's 100%. We need to get there. However, we're gonna include some error, right? So percent error right now is what we're looking for. And in this case will be x. X is gonna be left or right if we look at that percent. Yes, will be right here on the left, okay? We're gonna figure out how much percent error it has, and if it's less than 5%, we are good to go. If not, we say, nah, it should be trashed. Okay, so how much is that error in inches? So what we're gonna do is I'm gonna subtract my original and optimal diameter minus the actual diameter of this bolt, 0.33. So if I subtract, easy, I get 2 here, 0 here, 1, and 0, 0.02. So that's 0.02 difference in inches, more or less than 5% error. Let's find out. So step 1 completed, step 2, cross multiply, okay? Like this and like that. Butterfly method. So I'm gonna begin with my x here. What's 0.35 times x? Yes, 0.35x. Easy as that, okay? We can combine them. And then we have 0.2 times 100. Remember, there's a trick for that. What is that equal to? Yeah, moving the point twice to the right will get you just 2. Again, I move the point from here once and twice, so it becomes 2.0. This is the same as multiplying times 100, okay? You can always do this, of course. Yes, but you get at the end, you will get just 2, okay? That will be the answer. Okay, so step 2 is completed. Now step 3, divide to solve for x. So we're gonna do that right now. Copying the equation, 0.35x equal to 2. All right, so what do I divide by here? So that my x is by itself and free from any numbers in front of it. Yes, I need to divide by that number that's in front of it, right? Which is 0.35. Okay, 0.35 and 0.35. That way these two numbers cancel to 1. So 1x right here. What you're going to do is divide 2 by 0.35. Again, dividing by a decimal can be challenging, so let's do that right now together. So first of all, I need to make sure that my divisor is a whole number. So I'm going to go ahead and take this point, move it once and twice. Now it is a whole number. Okay, 35. Do the same with the dividend. So we got 2.0. No, we're going to move it once and twice again, and it becomes 200. Okay, that way we get the same result. Good. So how many times does 35 fit in 2? That is 0. Okay, if I multiply, I get 0. Subtract, I get 2. dropping a 0. How many times does 35 fit in 20? Again, not even once. Do the same, okay? The same here. Multiply, subtract, and I drop another 0. 200 now. Okay. How many times does 200 fit in... Sorry, how many times does 35? 0.35? No, 35. My bad. I'm just confused right now. Fit in 200. Okay, so if we do the math over here, we're going to find out that 2 times 35 is 70. So how many times can you fit 35 in 200? Well, I'm going to go ahead and say just 5 times. Okay, so let's multiply. 5 times 35. That's my estimation. Again, you get better at these estimations the more divisions that you do, long divisions that you do, you get better at these. 5 times 5 is 25, and 5 times 3 is 15, and then plus 2, 175. Okay, and that's, yeah, you can add another 35 there. So if I multiply, I get 175. Boom. Subtracting, I get, if I do the quick math, I get 25. Okay, awesome. And then I need to drop another 0 here. Yep, we need to do that. So how many times does 35 fit in 250? Well, I'm going to go ahead and say 7. Okay, good. All right, so I'm going to do this over here. 35 times 7. Okay, so 7 times 5 is 35. 7 times 3, 21, plus 1, plus 3, sorry, 24. 245, let's go. Boom. Okay, nice. If I subtract, I get just 5, okay? I'm gonna stop right there because the decimals are gonna go crazy here. So I'm just gonna stop right there. And since, I mean, all I need is a value for the error, I can stop right there. So my answer is approximately equal to 5.7%. Okay, that's my answer for X. So let's go back to the question here. Should it go to the package? Now, look at the error here. And look at the tolerance here. You have to have maximum 5%. Question, should it go in the package, yes or no? Yes, the answer is no. Why? Because the error is 5.7%. That's more than the 5% tolerance that it had. So no, because the error is 5.7%, which is more than 5. So no, it shouldn't go in the package. Please make sure you have all the questions completed before you request a stamp. Thank you.